Howdy, my name is Akil,
My name is Nicholas.
And my name is Joseph Chow.
and we are Team 7. This year at TAMUHack, our project is SixEyes. Now, a lot of us are students, and I'm going to tell you a problem that I face every day. I am an engineering student, and there's so many resources for me to learn. Wonders like Khan Academy, 3 Blue, 1 Brown, and the Organic Chemistry Tutor put out hours of video form content to help me learn my engineering topics. Furthermore, textbooks have all sorts of useful diagrams, content, words, and even Wikipedia and all sorts of other websites have bounds of knowledge that can be used for learning. So, why am I still struggling in school? It's the 21st century, right? I have everything. I have everything. The problem is using it all effectively and quickly. We have so much content right now, hours upon hours of videos. So when I want to solve a very specific problem, say in my circuit theory class, how do I know where in the video to go to? Do I jump to the 30-minute mark? Do I jump to the 15-minute mark? Or what page do I go to? What page in my textbook? What website do I go to? This is a question that has plagued many, many students and has cut drastically into study time. We've actually been overbogged with information, and SixEyes is a tool that helps us use it. Next slide, please. So what we did is we trained a data set that's actually capable of understanding engineering drawings, textbook drawings, as well as engineering text, textbook text, and not just engineering, really STEM. So it supports the medical field, the engineering field. We also have some math content, some data structures, and we built image embeddings. So what an image embedding is you take a particular image and then you represent it in a vector space. Now, we might be used to the 2D or 3D vectors that you might learn in Cal 2 or Cal 3. Our vectors are 718 dimensions. And with those vectors, we have grouped images based on their context. What this allows us to do is perhaps load all of our nodes into a particular system. For example, I can load all of my YouTube videos. I can load all of my textbooks. I can load all of that into our system. And then the next time I see a problem that has a picture that looks kind of similar, I can either grab a sheet of paper, draw it, and take a picture, or I can take a picture of the problem directly. And our tool is going to search through all of that content and find the exact second in the YouTube video where a similar problem appears so that I can, find what I'm looking for. Or it'll find the exact page in a textbook.
Right, so the SixEyes architecture is based on different groups of cloud programs. On the backend side, we have our data storage, which is in a data locally hosted or cloud hosted Redis storage on a cloud VM, and we have querying resources on that side. And we have a separate cloud which manages the frame ingestion service, where we take our videos, images, and documents, and we output the vector embeddings that we then use to determine what is closest and most relevant to our content. On the front end, we have a website, web application that queries the two databases for the correct information.
Now, that model, or if you could go back, the model that is in the green embedding service is something that I trained on TAMU textbooks, about the 10 that I've used throughout the school year. And it took a lot of compute power. And in fact, it takes about a second to process a single frame of content. And when you look at the video that might have 60 frames per second or compressed to 30 frames per second, it's really unfeasible to process 1 frame per second, which is why we have a cluster of RunPod nodes, which process the model in parallel using PyTorch, and they all have access to NVIDIA GPUs. Not the fancy ones, but just the RTX. And that allows for us to sort of get a massively parallel operation to cut down the time it takes to ingest new content. And once that content is ready, it only takes 1 or 2 seconds to search it in our vector database, as Redis is quite fast with Google Cloud Platform's offering. But now for the demo, the best part.
Yeah, last but not least, the demo. So this is the landing page for our application, SixEyes. Here you have an opportunity to drop your image, which we'll be doing right after we look at this resources tab. So here we have some resources already loaded in. These can come from textbook materials or even lectures. So documents and videos are all stored here. If you wish to add more, then you can simply drop an image here and it'll be submitted and go through processing. Once it's done processing, we can go ahead and submit an image of a tree, and our processed images will have some information regarding their similarity scores. And so we can see that this tree is highly similar to this red-black tree, which if I were studying this, I would probably want to go over to here and look at page 4 of this document I uploaded. Moving on, we have other similarity scores. This could be a similar topic or some other ones that might not be so similar. If you have a video, we could give you a timestamp where you can locate exactly where you need to go in order to help you solve this question.
The
And that is
crazy part
Project
about,
Six
oh, my
Eyes.
bad.
Go
Yes, the
ahead.
crazy part about all of this is that we didn't program something to just look at image similarity. We had an AI model learn what the diagrams are to effectively find what best matches your scenario. This isn't like Google reverse image that finds exact carbon copies. This is a semantic search who's going to make your academic life faster, easier, and more productive. Thank you.